go through the motions of watching them every single time. That's why I finally gave up on making you guys watch Khan Academy videos. Okay, today we are doing the mean value theorem in critical numbers. So in this chapter, we'll do maximums, minimums, concavity, things like that. Okay? So, but first we do the mean value theorem, which is actually, fairly basic type of thing. Okay. The mean value theorem connects the average rate of change to a derivative. We're putting them together. So, what we have going on with the mean value theorem is this. You have a line that might be going like this, something like that. Okay? So, you connect the endpoints of this squiggly line. And what we're saying is we find the slope of the straight line. Then we say, well, along the squiggly line, somewhere along the squiggly line, and it could be multiple places along the squiggly line, the slope of the squiggly line will match the slope of the straight line. That's the mean value theorem. And we're going to find all the places where the slope of the squiggly line matches the slope of the straight line. Now, most of the time, it's just one spot. Okay? Most of the time, you'll have a function maybe like this, whose slope is like this. And so right here, the slope would be the same. The slope of this line would be the same as the slope of the tangent line to the function. So if you find the spot where the tangent line is the same as the slope of the line between the two endpoints, then that satisfies the mean value theorem. Okay? So, mean value theorem sounds complicated, but it's not so complicated. But you have to follow this. There exists a number somewhere in between here where the first derivative is equal to the average rate of change over the function. Okay, from endpoint to endpoint. So, let's look at this first one. So, this is A, this is B. So, what we need to do first, because we have an A and a B and a C here, we have to find the slope of f of B minus f of A over B minus A. And somewhere, that's going to equal the first derivative of C. Okay? But we're not worried about that yet. We're finding f of B minus f of A over B minus A. So then we say, well, what is f of 3? Because B is 3 in this example. So it's 3 cubed minus 6 times 3 squared plus 12 times 3. 3 cubed is 27. 3 squared is 9 times 6 is 54 plus 36. So that should be 9 if I did my math in my head right. F of A is just 0. So if we put it into the function, 9 minus 0, f of B minus f of A, over B minus A, it's 9/3, which is 3. So we're saying on this function, there's at least one place that the slope should equal 3. But if there's more than one place, we should find more than one place where the function equals 3, where the slope of the function equals 3. How do we find slope in calculus? We take the first derivative. So f prime of x equals 3x squared minus 12x plus 12. And what we do is set it equal to the answer that we got in the first part, 3. Because we want the slope equal to c prime. Okay. So if we do this, move the 3 over. 3x squared minus 12x plus 9 equals 0. Factor out of 3. X squared minus 4x plus 3 equals 0. So this factors into x minus 3 and x minus 1. Does the 3 on the outside matter? No. So x would equal 3 and x would equal 1. Now, when you get your answers, are 3 and 1 within this interval of 0, 3? And the answer is yes. So 3 and 1 satisfy the mean value theorem. Oh, actually 3 does not. Excuse me. Because it has to be within the open interval. It can't be an endpoint. Okay? It can't be an endpoint. So 1 is the answer. There's only one answer for this one. So where x is 1, its slope will match the slope of the line created when we connect the endpoints. And that's the mean value theorem. Now let's do a little more complicated mean value theorem one. One that has a square root involved. All right, same process. A equals 4, B equals 13. F of A, F of 4 equals 3 times 4 is 12 minus 3 is 9. The square root of 9 is 3. F of 13 is 3 times 13 is 39. 39 minus 3 is 36. The square root of 36 is 6. So the slope is 6 minus 3 over 13 minus 4, which is 3 over 9, which is 1/3. So that's the slope. So then what do we do next? Find the first derivative of our function. Well, our function is 3x minus 3 to the 1/2 power. So it's 1/2 of 3x minus 3 to the negative 1/2 times, we're doing the chain rule. You got to remember the chain rule. Times what? 3. So 3 over 2 square root of 3x minus 3 should equal 1/3. The first derivative equals the slope of the endpoints in the mean value theorem. How in the heck do we solve this? You can. This is like a proportion, right? A fraction on each side. And when we solve proportions, we cross multiply. So 2 square root of 3x minus 3 should equal 9. Divide by 2. The square root of 3x minus 3 equals 9/2. How do I get rid of a square root? Square both sides. So 3x minus 3 equals 81/4. Move the 3. If we add 3 to both sides, I'm adding 12/4 to this side. So I get 93/4. Thanks, Kate. And then to get rid of the 3, multiply each side by 1/3. So that gives us 31/4. Is 31/4, which is 7 3/4, in between these two numbers? And the answer is yes. So 31/4 is our answer.
Great thinking.
And then we'll have these fun ones, which it says, is his justification complete or not? Doing the mean value theorem. So, below is his attempt to write a formal justification that the equation, the first derivative of this equals 8, and the solution is somewhere in between 1 and 3. So his justification is he found h of 3 minus h of 1 over 3 minus 1, which is 8. Okay? Because if you plug it in there, you get 8. Okay? So according to the mean value theorem, the first derivative should equal 8. And it must have a solution somewhere in between 1 and 3. Now, it could say that his justification is complete, or he didn't establish the average rate of change is equal to 8. Well, I think he did right there. The average rate, ooh, I didn't mean to do that. So right here, he established the average rate of change is equal to 8. So we know he did that. Okay? Did he establish that h is differentiable? Because I don't think he ever took the derivative of this, right? Okay? So he didn't take the derivative of that. Or he didn't say that it was differentiable over this thing.
The first time you circled that paragraph at the beginning, that doesn't count. Polynomial and exponential functions are differentiable.
Yeah, it says differentiable.
Does that count?
Oh, yep, that is. So his justification is complete. Because he has to say that it's differentiable and continuous. He has to show that this is equal to 8. He has to show the average rate of change is equal to 8. So, yeah. All right. For this one, can we use the mean value theorem to say that the first derivative of x equals 16 has a solution somewhere in between 3 and 5? What was not shown here? Well, if we put in a 5, what do we get? 32, right? If we put in a 3, we get 8. 32 minus 8 is 24. Divided by 2 is 12. It's not equal to 16, is it? So the first derivative would have to equal 12, not 16. So the average rate of change is 12, not 16. So that's why that wouldn't work. So you go through and figure out what's going on. Look at why things are no and see if any of the no's make sense. All right, the table. Can we use the mean value theorem to say that the first derivative should equal 40 has a solution somewhere in between -3 and 0? So in between -3 and 0, we have to find the rate of change. So we take 230 minus 110 over 0 minus negative 3. So this is what, 120? And this is a positive 3, so that should equal 40. So the first derivative has to equal 40. Well, that checked out. Is it differentiable? It says it's continuous, but do we know that it's differentiable over the whole function? Because we have to know it's both differentiable and continuous over the whole function to work. Since we don't know it's not that it's differentiable, we cannot say that it works for the mean value theorem, because it has to be both differentiable and continuous. Okay, so you'll have problems like that. There'll be a couple assignments over the mean value theorem. Then critical numbers.
Oh my gosh, another one?
Yeah, we're doing 2 today, all at once though. So critical numbers help us find minimums and maximums. So where the first derivative is equal to 0 is going to be a critical number, okay? Or where the first derivative is undefined, that's a critical number, okay? That tells us information that we need to know. So most of the time we'll be looking for this, but every once in a while we'll also include that into critical numbers, okay? So where the first derivative is equal to 0, or where the first derivative is undefined, is a critical number. So how many critical numbers does this have? Well, what do you think we should do first? Take the first derivative. The first derivative of this is 3x squared plus 2x plus 1. We set it equal to 0. Can that factor? I think so. 3x and x, 1 and 1. Uh-oh, that can't factor. Because if we go plus and plus, we get 3x squared plus 3x plus 1x makes plus 4x, not plus 2x. And we can't make a minus because these are all pluses. So what we have to do is do the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. What's 4 minus 12? Negative 8. If it's a negative number, they're imaginary roots, right? No critical points. I want to just look at what that graph looks like. X cubed plus x squared plus x. Oops, not going to see very much here. Zoom 6. Yeah, okay. This graph, what happens is it goes up, it has a little turn, and it keeps going up. Is there a maximum or minimum that occurs there? No, it just constantly goes up, so then it's not going to have any critical points. So if you have questions of what's going on, then what you do is you just look at the graph, and it can kind of help you out. Like this one. Does this have any critical points? Well, what's the first derivative of this? E to the x squared plus 2x times plus 2. So this doesn't equal 0, okay? But you set this equal to 0. Well, 2x plus 2 equals 0. X, 2x equals negative 2, so x equals negative 1, okay? Because e to any power cannot equal 0, because e to the 0 is 1, so you can't take e to a certain power to get 0. You just can't. So, again, if you question this, let's graph it. So you take e, and you graph the original, not the first derivative. E to the x squared plus 2x. If we graph it, right here, it has a minimum point, correct? At -1. Critical number, minimum point are the same things. Where the maximums or minimums occur are the critical numbers. Okay. This one, does it have any critical points? Now, some of you will cheat and go straight to the graph and see if it has any critical numbers. If we don't want to cheat, okay, we would use what? Quotient rule. X plus 2 times 2x minus x squared minus 3 times 1 all over x plus 2 quantity squared. So it's 2x squared plus 4x minus x squared plus 3. Be careful there. You got to distribute your negative sign through the second set. Over x plus 2 quantity squared. So it's x squared plus 4x plus 3 over x plus 2 quantity squared equals 0. Does the denominator even matter here when I'm saying it equals 0? And the answer is no, because if I multiply both sides by x plus 2 squared, what's 0 times x plus 2 squared? 0. So it really doesn't matter. So I just have to factor this, which is easy. X plus 1 times x plus 3. They add to 4. They multiply to be 3. So our two roots are -1 and -3. You don't understand this doesn't matter? Because if we multiply both sides by x plus 2 quantity squared to get rid of it from this side, we multiply 0 times x plus 2 quantity squared. 0 times anything is 0. Okay? All right, I think I'm almost done here. Yep, last one. Okay, does this have any critical points? No. All right, should we do the quotient rule for this? X squared minus 4 times, what's the first derivative of 1? 0 minus 1 times 2x all over x squared minus 4 squared equals 0. Well, I just get -2x equals 0 here, right? Because the denominator just multiplies out and cancels. So you get -2x equals 0, so x equals 0. If we want to check that, why it is the way it is, just put 1 over x squared minus 4 graph. And what happens is it's a function that looks like this, where we have an asymptote here, an asymptote here, and it goes like this, it goes like this, and it goes like this. And that's why it has a maximum right there. Okay? So I will put out the multiple assignments over this.